In this video, we'll discuss ions. Ions are just atoms that either gain or lose electrons to become positively or negatively charged. When they lose electrons, they become positively charged, and we call those cations. When they gain electrons, they become negatively charged, and we call those anions. This happens because atoms need 8 valence electrons to be stable. Now there are two exceptions, hydrogen and helium. They only need 2 valence electrons to be stable, but they do need a full outer shell, and they do lose or gain electrons to fulfill that 8 valence electron outer shell. We call that the valence shell. The way to determine the number of valence electrons in an atom is to look at the group. Group 1 they all have 1 valence electron. Group 8, they all have 8 valence electrons. So the number of valence electrons corresponds to the group number. Now this is not true for transition metals. It's only true for your main group elements. And when you look at the periodic table, you might see that this doesn't say 3, it says 13, but it also says 3A. So your main group elements, they'll have an A after. So 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. Metals tend to lose electrons and they become cations. And so if they lose 1 electron, the charge would be positive 1. If they lose 2 electrons, it'd be positive 2. If they lose 3 electrons, it'd be positive 3. When this happens, they also lose that outer shell. So in this example of sodium, instead of having three energy levels, you only have 2 after you lose that valence electron. Notice the name doesn't change, it's still sodium, so it could be a sodium atom or a sodium ion. With nonmetals, they gain electrons. So if they gain 1, they'll get a -1 charge. If they gain 2, a -2. If they gain 3, -3 charge. And when this happens, that outer shell becomes full. So instead of losing an energy level, they'll fill an energy level. But the name does change. So instead of having an oxygen ion, it's an oxide ion. We change the ending to "ide." We have Lewis structures for atoms and for ions. Atoms represent the number of valence electrons, but with ions it's different because cations, we show it with no valence electrons in brackets with the charge, but anions we show a full valence shell, brackets, and charge. And this is because cations lose that outer shell, they donate the electrons, where anions gain the electrons to fill that outer shell. Now, the electron configuration of ions, of many different ions, can be the same, and it will match that of a noble gas. So oxygen and fluorine are the elements before neon, the noble gas. Neon has a full outer shell. Fluorine almost has a full outer shell. It needs 1 more electron. When it gains that extra electron, the electron configuration changes from 1s2, 2s2, 2p5 to 2p6. So that 2p orbital is full now, and so that gives us a total of 8 valence electrons. Now the same thing is true for the metals that come after that noble gas. Since sodium, for example, will lose 1 valence electron, the electron configuration changes. So instead of having that 3s1 disappears because it loses that 1 electron, and you get 1s2, 2s2, 2p6. And so we call all these that have the same electron configuration, we call those isoelectronic.